For this question, we are given a equation about a sphere, and we are to find the center and the radius of the sphere. So first of all, the general idea for solving these type of questions is to give it to form of a general sphere equation where you have the centers of being A, B, and C as shown here, and the r would be on the right side of the equation being squared. So what we can do is reorganize the equation in a way and essentially complete the square from there. Should be able to solve this question. So first of all, I'm going to move some of the parts so move all the x's together, all the y's and the z's together, and then I can complete a square more easily that way. So I have x squared plus 6x plus y squared plus 8y and plus z squared minus 4z equal to -4. I'm going to move the -4 to the other side. Okay. And then now I'm just going to complete the square. So for each term, essentially what I'm going to do is look at the non-squared term, and usually that term is for the two x, y being the other constant that we are trying to complete the square with. And in this case, it will be 3 since 2xy will be 6x. So right there, I will complete that square, the x squared, with x squared plus 6x plus 3 squared. Since that's the y we solved for, and then essentially the same thing for y and x. So y squared plus 8y, so 2xy, and the other term would be 4, so plus 4 squared. And then z squared minus 4 squared, 4z, and that would be minus 2 for the other term, but we can square that, so it'll be -2 squared. And over on the other side, we had -4, but we also have to add all the green terms. Since we added that, we have to add it to both sides to keep the equation valid. So add 9 for 3 squared, 12, 16, and then 4. So then these two will cancel out, and we have 25 on the other side. And then let me just move down a little. Complete the square from there. So it's x plus 3 squared plus y plus 4 squared. Alright, I need to get rid of this. Plus z, in this case, would be plus -2, which is minus 2 squared, equal to 25 on the other side. So from here, can make this more clear. I'll rewrite it as x minus -3 squared, and it will be y minus -4 squared plus z at minus 2 will just remain that way, equal to 5 squared. And each of these parts are the coordinates for the center of the sphere, and 5 would be the radius, as we can see from the equation above here. Just a reminder that all these signs for the center will need to be minus, so that can be a tricky part. and the 5 would be our radius, and let's see. So, all right, let me just erase it then. So in this case, we had -3, -4, and 2. And then the radius was 5. So D will be the answer. So for this question, we are asked to find the magnitude of a resulting vector. So there's 2 steps, I think, for solving these type of questions. So first, we need to find that resultant vector. Gaussian res. And second, we can just take the magnitude of it. So going with that, first of all, 5b, just b equal to 5 times each component of b. Let's make that a vector. So 5, 10, -10. And then we have 2a, which would be 4, 2, and -6. And we can do 5b minus 2a, and the resultant vector would just be the component. 5b's component minus 2a's component would equal to 1, 8, and that would be -4. So that's part A, part 1. And then part 2, taking the magnitude of the resulting vector, we can have 1 squared plus 8 squared plus -4, which is 4 squared. So this is 1 plus 64 plus 16. 64 plus 16 is 80, so this is square root of 81 equal to 9. So let's look at the question. I can move that out of the way. And that will be option D here.
For question 3, we are given 2 vectors that are orthogonal, and we are to find the variable that's in between. So for orthogonal vectors, we got to remember that the dot product of the vectors will be 0. And that is because dot product of, let's say, A and B takes the length of A times the length of B times the cosine of the angle in between. So if it's orthogonal, that means the angle in between here will be 90. And cosine of 90 is 0. So this whole thing is 0. So for orthogonal vectors, their dot product would be 0. So we could use that. When I dot these two together, we get something like, so the dot product will equal to 2 times 4x plus x squared plus 15. Right? That would equal to 0 as they're orthogonal. Rearrange a little. We have this. And we can factor it like so, x plus 3 and x plus 5. So then we have the solution of x equal to -3 or -5. So for question 3, that would be A. For question 4, we're given vectors A and B, and we're to find the comp of A onto B, which is just a scalar projection. So first, let's just write down the equation for comp. A onto B will equal to the dot product of A and B over the length of vector B. So we can just plug in, but before that, let's write A and B in vector form, and notice there's I, J, and K, meaning that these are actually 3D vectors. So A would be 3, 0 for J, and -3. B would be 1, -1, and 0. So the final answer for comp would just be the dot product, which is pretty simple since there's zeros. So it's 3 plus 0 plus 0 over the length of B, which in this case would be square root of 1 squared plus -1 squared. This case would be 3 over root 2, which would be answer choice A for number 4. For number 5, again, we're given two 3D vectors of A and B, and we have to find C2, which is just the second component of the cross product. So let's just cross A and B. I'll write it here. A 201 and B 311. So we cross this. We have, so ignore the first row, 0 minus 1 will be -1. And then ignore the second column, rather, it'd be 2 minus 3, but the second element is, you take the negative of that, so it will be actually 1. And then, again, ignoring the third column, it will be diagonals 2 minus 3, 0 rather, which would be 0, and C2 here would just be the second element, which would be 1. And answer choice C. For question 6, we're given 4 points A, B, C, D, and we are to find the area of this parallelogram. So for these, I'm just going to demonstrate and draw using a 2D surface. So that's what we got. So here, let's set an anchor of A, be 0, 0, 0. And then B, let's say B is here, is 1, 0, 1. And then we go maybe 2 over. We have C here, and D would be here. So this, when connected, will be our parallelogram. And in this case, we can say that this, let it be P vector of P, and vector Q here, as in AC be Q and AB be P. And in this case, we can say that the cross product between P and Q, and the length of that will be the area. And again, I will show you why. For here, that should be R. Here, if we draw a little perpendicular line down, we can see that the area of the parallelogram should be base times height. If we go back to the cross product here, if you remember, a cross product, let's say P cross Q equals to the length of P times the length of Q times the sine of the angle between. In this case, this is the angle in between, and if you look at it, this height here, let's say it's h, right? H is just the length of P times sine of theta. right? Theta sine is opposite of adjacent, and times the opposite of the hypotenuse times the hypotenuse by the sine of angle, you get the opposite side. So we can replace this part, right, with h, and you will see that this is just the length of q times h. And here, going back to the diagram, length of q is the base, right? This is the base, times height is just the area of the parallelogram. So with armed with that knowledge, let's just first of all get the vectors p and q. Right, this is really simple. Since a is 0, 0, 0, p will be just 1, 0, 1. Right, it'd be b minus a. And then q will be c, ac. So c's coordinate minus a's will be 2, 1, 0. And when we cross this, we get, right, looking at the first column, so we have 0, minus 1. That should be positive. Wait, 0 minus 1 is negative 1, sorry. Second column, the negative of 0 minus 2. And third column, it'll be 1 minus 0. So this is the cross product. And the area is the length of this. So I want the length of this. That would be equal to negative 1 squared plus 2 squared plus 1 squared. In this case, the root 1 plus 4 plus 1 is root 6. That would be answer choice C. And for number 6, choice C would be the correct answer. Thank you for watching this video. The past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.